Hey folks, Mr. Hartzler here, and I want to talk to you about factoring trinomials. And I think we should start off with an example here. Also, GCF folks, always look to see if there's a GCF, and that stands for greatest common factor. Greatest common factor. So what do all three of these terms have in common? Right? That's the greatest common factor, the largest thing that they all have in common. And that's going to be a 5 and an x, because they all could be divided by 5, and they all have an x in them. And when I'm factoring things, right, I factor it out, it's also like dividing out. So 5x cubed, I'm dividing it by this 5x. And the result is an x squared. The 5's would cancel. X cubed divided by an x, I'm down to x squared. So then 10x squared divided by 5x, I'm left with 2 and only 1x, right? Start off with 2, take out the 1, I'm left with 1. 5x divided by 5x, and I'm left with 1. So now this is starting to be factored, but it's not completely done. I am only completely done if I pretty much have all of these split up, so there should be no x squareds anymore for the most part. So this 5x, I'm just going to bring straight down. And when I'm factoring trinomials, right, this should turn into 2 sets of parentheses. And I want to find things that multiply to get me my 1 and add up to get me my 2x. So what things multiply? I'll write a little x here. Multiply to get me a 1. And that's things like 1 times 1 and -1 times -1. Sometimes those negatives play a pretty important role, so don't forget about those. And then adding up. I'm supposed to add up to get a 2. 1 plus 1 gets me 2. -1 plus a -1 gets me a -2. So that one doesn't work, but that top one does. And that means I have a 1 here and a 1 here. What things multiply to give me x squared? Well, it has to just be x and x. Oh, and remember, those are positive ones, so they stay positive ones here. And that is done. I am completely factored. One small thing I could do if I wanted to be super fancy is leave that 5x out in front, but x plus 1 times x plus 1, I can rewrite that as x plus 1 squared. So again, that is the one that is fine for almost everybody, and this is just really fancy way of writing it. Let's check out our next one. So these are more classic trinomials. I again want to find things that multiply to get me my last term and add up to get me my middle term. So what things multiply to get me 6? A 1 and 6, a 2 and 3, and then of course negatives of all of that. But since everything's positive here, I'm just going to look at positives for a little bit on this one. And then those are multiplying, so I need to figure out what those all add up to. That top one gets me 7. This one gets me 5 though, so I know it's going to be these things. 2 sets of parentheses. What multiplies to give me x squared? Has to be an x and an x. And then that's where this 2 and 3 come in. Those are the other parts here. And it doesn't matter the order. That is the exact same as this. So I'm allowed to switch those two things and everything is still fine. So if you wrote 3 and 2, not a problem. And I can always check this by foiling it all out. X times x gets me x squared. X times 2 is 2x. 3 times x is 3x. 3 times 2 is 6. And then I have like terms in the middle. X squared plus 5x plus 6. Got back to my original. So that is in fact how it factors. Now let's look at our next one. I do have a negative in the middle, so I do want to check my negatives now. So what things multiply to get me that 10? I have a 1 and 10 and a 2 and a 5. That's pretty much it. But I also have -1 and positive 10, or a -2 and a positive 5, or a negative, oh sorry, I messed that up. It has to be a -1 and a -10, or a -2 and a -5. And that actually is going to tell us which one works, right? This one right here. I want things that multiply to get me a 10. -2 times -5 gets me a positive 10. And I want them to add up to get me this -7. And -2 minus 5 gets me a -7. So I'm going to have my two parentheses again. X is in the front because that's the only way to get my x squared. And then the second part of each set of the parentheses comes from this thing. What multiplies to give me 10 and adds to give me -7, -2, and -5. And again, you could switch these two around if you want to put the -5 part in front. Doesn't matter. Let's keep going and try some more of these examples. So this one, again, what multiplies to get me a -6 adds to get me a 1. So multiplies to get me a -6 adds to get a +1. Multiplies to get -6, let's see, -1 and +5. And -3, +2, or a -2 and a +3, or a -5 and a +1. Oh, sorry, not 5s, 6s. Those have to be 6s in order to multiply. And I need to add up to get 1. -1 plus 6 gets me 5. -3 plus 2 gets me a -1. That's close, but I want a +1. -2 plus 3 gets me a +1. That's my ticket. These two numbers multiply to get me my -6, and they add up to get me my 1. So I need to multiply to get me my last term, add to get my middle term. Two sets of parentheses. Since this is just an x squared, and you'll notice a lot of them are like that, it's just x's in front, and then my -2 and my +3. Ooh, switch that up, careful. Careful, gotta take them exactly as they are. I can't switch it and make it a -3 and a +2 because that won't be the same answer. And then my one off to the right, I need to multiply to get me a -6. So let's break that up. A -1 times 6, a -2 times 3, a +2. Oh, I should keep writing negatives first, huh? A -3 times a +2, and a -6 and a +1. But I want to add up these terms and get my middle one, that -5. So what's -1 plus 6? +5, darn it. -2 plus 3, that's a 1. -3 plus 2 is -1. And then -6 plus 1 gets me my -5. Awesome. That's my winning combination. X's in the fronts, and then that combination in the back, -6 and a +1. And again, the order doesn't matter. I could have had a +1 front and a -6 in back. All right, let's keep going. Now I get to a challenging one. So here I have x to the 4th and an x squared. We're going to pretend for just a moment that it's not like that. We're going to pretend it's like this. What multiplies to get me a 2 and adds to get me a 3? 1 times 2 multiplies to get me a 2. 1 plus 2 adds to get me a 3. So my stuff is going to split up into a 1 and a 2 with x's in the front. Both of those are positive. But I don't want to multiply to get me an x squared. I want to multiply to get me an x to the 4th. And this is an x squared. So all I have to do is tweak that right there. X squared and an x squared. I'd said in the beginning that usually you want everything to be split up into normal x's, but x squared plus 1 cannot be broken up any further, and neither can x squared plus 2. So since there are only 2 terms in each of these, I would look towards my sum of cubes or my sum of squares formulas. And you'll notice that neither of those are sum of cubes or sum of squares. And actually, sum of squares wouldn't even apply here anyway. So there's that. And one more. So far, all of the ones we've had, this front number, there was a 1 there. Nothing was written, so it was assumed to be a 1. If it's not a 1, if it's anything but 1, you have to do this. Multiply your first and your last term together. That gets you a -10. You now want to find things that multiply to get to this number, but still add up to get you your middle number, in this case a -9. So what things multiply to get me a -10? A -10 times a +1 will work. And if I add those two things up, I get a -9. So that's my winning combination. But I have to do some weird stuff from here. So now I'm writing 2x, and I'm actually going to write this chunk out a little bit differently. Instead of -9x, I'm going to write a -10x and a +1x, and then a -5. You'll notice I have not made any changes here except how it looks, right? This original formula up here, this one, and this one are still equal to each other. They're still equivalent. Oh, I can't write words. They're still equal. They're still equivalent because negative 10x plus 1 still gives me that negative 9. Now I'm going to do something that you might not have seen yet, but this is called factor by grouping. Factor by grouping. If you haven't seen this yet, you'll get to it, and this is great foreshadowing. So, in this front term, what is the GCF? It's a 2x. If I divide everything here by 2, this is x squared still from the beginning. Everything here has a 2x in it. If I divide that out, I'm left with an x and a minus 5. Then this other one, I want to factor out a GCF, and there actually isn't any. It's just a 1. And then I'm left with the x minus 5. You'll notice that I have this in common, right? Because there's this big term over here and this big term over here. Both of them have an x minus 5. So I'm going to pull that out in front. And I'm left with a 2x and a plus 1. Now I'm factored. That was a little bit tricky, I know, but this is where a does not equal 1. These are kind of tricky ones anyway, and this is mostly foreshadowing for a lot of you because you won't have to do these for a little bit longer, but they are coming, so keep an eye out for them. Hopefully, this was helpful, folks, and I hope all of you have a great rest of your day.